So for our lab exercise, you are going to implement the recursive functions for getHeight and getCount. So first, when we're calculating the height of the binary search tree, a binary search tree can vary dramatically depending on the order the items were added, because depending on what numbers are bigger or smaller than the node, it can go many different ways. So one measure of a tree shape is its height, and that is significant because if you had the worst possible case where everything was always creating deeper and deeper to one side, so it was just a straight line to one side, it becomes longer to search that tree because there's more steps. So the height of any node in a tree is the number of edges, links, or steps on the longest path from that node to any leaf node under it. A leaf node has a height of 0. In our case, if we have an empty tree, we use the sentinel value -1. You can compute the height of a binary search tree using post-order traversal and the following recursive definition. So we have int getHeightHelper here. It takes the pointer of the bstree node. And what's going to happen here is if p is null or -1, that's your base case. If p is not null, you're going to get the max of the height to the left children compared to the height to the right children plus 1. And then for step 2, it can be useful to know how many nodes a binary search tree contains, so all the children in the tree entirely. And in this case, we'll use the getCount helper, which takes the same, it just takes the pointer. And it will return the count of the number of data items in the tree. And again, if it's null, there's nothing, so there's 0 items in the tree. If it's not null, you count how many children are to the left, how many children are to the right, plus 1. So for the detailed implementation, you're going to use these files. bstree.h is a templated binary search tree implementation that have the getCount and getHeight functions in there. config.h controls or the ability to enable or disable these functions, and test is your main program. When you are done, or you will be implementing getCount and getHeight, you'll find the prototypes and partial function definitions in lab 10. You have getHeightHelper here, and some comments giving you the instructions for that. And you'll have getCountHelper here. So just follow along what these instructions tell you to do. When you are done, your output might look something like the following, where you can add in the keys and watch your tree grow. In this case, the right or greater side is up and the left or lower side is down. And you might end up with things like this.